All right, so this is the third part in our video of a titration of weak acid with a strong base. This is going to cover the halfway point and the next one. So at 25 milliliters, which is our next blank we want to fill in, we know that that is the halfway to the neutralization point because we have, we know that the equivalence point is 0.05 liters. This is 0.025 liters. And at that point, the pH is equal to the pKa. We calculated the pKa in the last video based off of this Ka value, and that's 4.74. So I'm good there. All right, so now for the next one, 37.5 milliliters of NaOH. So if we have 37.5 milliliters of NaOH, let's figure out how many moles that is. We have 0.1 molarity solution. That's 0.00375 moles of NaOH. So I'm going to set up my table like I've done before and not worry about the water. I, C, and E, and I'm starting out with the same 0.005 moles of that, 0.00375 moles of that, none of that. So we can see that this is going to run out before this. So all of this is going to get used. So my change value here is negative. Here it's negative. That's my change value is the same because of this 1-to-1 ratio. And over here it's a positive because that's being produced. So at the end of the reaction, what's left in the reaction vessel is this mixture. So I'm going to again use the Henderson-Hasselbalch equation, pH equals pKa plus the log of A minus over HA, 4.74, plus the log of 0.00375 over 0.00125, and I get 5.22 for that. So I can fill that out. So for the next step is where I'm at 49.9 milliliters of NaOH, right before that equivalence point. So let's do it the same way that we've been doing, that we just did in the previous problem. I've got 0.00499 moles of NaOH having been added. That is the limiting reagent. That's the one that's going to run out first. So I know that at the end point of this, or I shouldn't really call it the end point, but at the end of this reaction, or the equivalence the equilibrium point, that value is going to be 0. So if I've started out with this 0.00499 moles of that, start out with none of that, and start out with my same 0.005 moles of that, all of this is going to get used up because I'm before the equivalence point. I'm going to make that same amount of the conjugate base. So that's going to be the equilibrium value of that. And I'm going to use up that number of moles of the acid. So at the end of this, a lot of zeros here, I've got that. So I can use my Henderson-Hasselbalch, the base over the acid, the same 4.74 plus the log of 0.00499 over 0.00001, and I get 7.44. Look at the big jump here. look at the big jump from when I was pretty far from the equivalence point till when I'm just about there. I go from 5.22 to 7.44. So that's a big jump there. So I'm going to put that in here.